Through point 6, let's jump in. Here we go. Just recapped what we saw in 2.2, 2.3, and 2.5. Now we're all set up for the very last type of limits we're going to discuss before we get into defining the derivative and what that's all about. Okay, so what do we have here? Limits at infinity. A limit at infinity is pretty much identical to end behavior. End behavior is a topic that would have come up in pre-calc when you're studying the graphs. A lot of times of rational functions, you talk about end behavior. It's what happens to the y value as either x goes to infinity or as x goes to negative infinity. So we've had limits, right, where our answer was infinity or negative infinity, but now we're thinking x approaches infinity or x approaches negative infinity. So a good example to develop this idea is f of x equals 1 over x, which you see right there. Let's think about, so it kind of has that shape. It's got the two branches, a vertical asymptote at the y-axis. It also has a horizontal asymptote at the x-axis. Let's take a look at the limit as x approaches infinity for our function 1 over x. So the limit as x approaches infinity, all right, we're thinking as x gets larger and larger and larger, what would happen to the y value as the x value gets bigger and bigger and bigger? And say, well, because of this horizontal asymptote, as x gets bigger and bigger, and we don't see much here, right? 2 and 3 and 4. As x gets bigger, that y value is coming down and it never actually reaches the x-axis, right? It never reaches y equals 0, but it gets closer and closer to it as x gets bigger and bigger and bigger. So the answer to the limit as x approaches infinity here for 1 over x is 0. How about the limit as x approaches negative infinity for 1 over x? Well, we'll look at the opposite side. We'll think, okay, the x values are getting more and more negative. Well, it's also headed towards the x-axis or y equals 0. Of course, it's on the underside this time, but there is still that horizontal asymptote, so it's going to approach 0 for that one as well. What we want to do is develop an intuition for where limits like these are going without the use of a graph. Then we'll be able to do more advanced situations. So I'm going to look at this a little bit more carefully. I just want it to really land on us just why these answers are 0 without basing that on a graph, but like maybe thinking about it in other ways. So think about the limit as x approaches infinity for 1 over x. That x value, I know I got the graph there again, but okay. That x value, that denominator, is getting bigger and bigger and bigger and bigger. Well, if the denominator is getting bigger and bigger and bigger, that means we're dividing by larger and larger values. If we're always dividing by bigger and bigger values, then the value of the entire thing is getting smaller and smaller and smaller in the sense that it's shrinking down to 0. So I made a quick table here, just again, not that we would need to use a table for something like this, but just to develop that kind of that intuition, that sense of why this is going to 0. So, you know, maybe you take like x equals 10, 100, and 1000. So x is getting larger and larger. Well, 1 over x for 10, x equals 10 would be 0.1, then 0.01, 0.001. As x gets larger and larger, the value of the function is shrinking down to 0. Something similar as we approach negative infinity. Maybe here we can take negative 10, negative 100, negative 1000. If we plug into the function, negative 0.1, negative 0.01, negative 0.001, again, we can see those numbers are getting closer to 0 from the negative side. All right, that's what we see in the graph. And so that's headed towards 0. So kind of what we want to develop is, okay, if my denominator is getting very, very big, that means the value of the whole thing is getting closer to 0, and either way it works. Right? Okay. One last little note at the bottom before we get to the next page. Note that these are always one-sided limits. Yeah, if you take a limit at infinity, either approaching infinity or negative infinity, that would have to be a one-sided limit because, think about going to infinity. I have to approach just from the left. I can't go to the other side of infinity and work backwards, right? And similar for negative infinity, I can only approach that from the right side. I can't go to the other side of infinity. Okay. It's kind of funny to think about that. From here, the rest of this section is just a whole bunch of examples, and there they are. We've got 10 of these. There are going to be some similarities. It turns out A, B, and C are all similar. Really, B and C are obviously very similar, but all three of these have a similar feel. D and E, right, there's a connection there. They both have sine x. F, G, and H, all going to be kind of another sort of category of these sorts of problems. And then I and J are just kind of two additional problems that kind of step it up a little bit. All of these, though, will use that theme of, are we dividing by infinity and that sort of thing. So right now, let's jump in to our first couple of examples. Switch cameras. Okay. Here we go. Example. Find the limit. The limit at infinity. And part A, the limit as x approaches infinity. 3 plus 2 over x minus 1 over 5x squared. So what we'll do here is think, okay, I'm taking the limit as x approaches infinity. I notice that I've got 3 terms. I don't think we've ever had a limit question where we're simply adding or subtracting different terms. Maybe like within a rational function or something. But okay, let's take a look. What we can do here is look at each piece individually. So we can say, okay, the limit as x approaches infinity for 3. If you think of the graph of 3, that would just be a horizontal line, y equals 3. So as x gets bigger and bigger, well, that y value is always just going to stay right at 3. So that one, nothing will happen. It's just going to remain at 3. This next one, though, as x gets bigger and bigger and bigger, 2 over infinity, where is that going? To 0. And finally, 1 over 5x squared. Well, again, infinity goes in. Infinity squared is still infinity. 5 times infinity is still infinity. So this is really like 1 over infinity. That would be going towards 0 as well. And so our answer here is simply 3. I'm kind of curious to know what that graph looks like. I won't do it, though. I'll let you guys, maybe in a minute, we'll come back to it. We might graph a couple of these sort of all together. But there you go. Yeah, we got that division by x. So, okay. Let's take a look at this next one. The limit as x approaches infinity, 4e to the negative x. Now, this is interesting. If you thought about infinity getting plugged in here, that's not all that helpful, right? 4e to the negative infinity. So let's not think of it that way. Let's think of it like this. The limit as x approaches infinity. Hey, doesn't that negative exponent, we could convert this to a fraction 4 over e to the positive x, right? And now maybe we can see it. 4 over e to the x as x goes to infinity. Well, e raised to the infinity, right? The exponent is infinite. Well, that's going to give us infinity, right? So really, this just boils down to 4 divided by infinity, which would go to 0. Probably, okay, just one thing I want to note. We often write things like this. This is not actually mathematically correct to plug in infinity that way. Instead, we should write something like this. As x goes to infinity, e to the x goes to infinity. That would be the mathematically correct way to say it. But this is helpful just kind of for developing that intuition. Plugging it in, e to a really, really big number that keeps getting bigger and bigger, well, that would be infinitely large. Okay. And then how about this one? X going to negative infinity. Same thing, but now negative infinity. Oh, this is interesting. Let's see here. If we were to plug in negative infinity just to the e to the negative infinity, isn't that e to the positive infinity? Which is infinity. And here we're not dividing by it. That's 4 times infinity after we plug in. So this answer is infinity. Okay, very cool. Hey, let's graph these super quick. Always like to do that. Let's start with 4e to the negative x. We'll be able to see it from both directions. So as x goes to infinity, yep, that's going down to 0. There's that horizontal asymptote. As x goes to negative infinity, well, it gets so big so quickly. You know, if we were to walk out, well, that y value is huge. It's going to positive infinity for sure as x gets less and less. And I'm actually really curious about this one. 3 plus 2 over x minus 1 over 5x squared. Okay, weird. Look at that kind of that shape. That is bizarre. I'm trying to wrap my head around what's happening here. It seems to me, okay, it's definitely got a vertical asymptote happening at 0, because that would cause it to be undefined. But it's got some weird behavior around 0. So here, this one's kind of more normalish, right? It just drops down, goes to negative infinity. But on the other side, you know, it is dropping down to negative infinity. But if we think of it going this way, it's shooting up, hits a peak, and then kind of does that. And both sides have this horizontal asymptote at what looks like y equals 3 right there. So yeah, that makes sense. As x goes to infinity, the y value is leveling off there at 3, and that was our answer. Well, that's interesting. Okay, let's stop this video here. We'll do a couple of more examples in the next one.